8.4, day 2, we're looking at the determinant of a square matrix. And so we're going to find the determinant of square matrices. So if A is a square matrix of dimension 2 by 2 or greater, then the determinant of A is the sum of the entries in any row or column. So important to note that it's any row or a column of A multiplied by their respective cofactors. So for example, expanding along the first row yields, so this is the determinant of the first number by the cofactor of that number, A12 times C12, and so forth. Applying this definition to find a determinant is called expanding by cofactors. So let's try that, the determinant of a 3 by 3 matrix. Now we're going to take a look at two different methods in order to find the determinant of a matrix. So I'm going to go for the first example, and the first example has to do with expanding by cofactors. We need to find the determinant of A. And so how to find that using this formula is that to find the determinant of A, that is going to be A11 times C11 plus A12 times C12 plus A13 times a cofactor 1, 3. So let's take a look. Remember that the A values here, A represents just the numbers in each placement here. And so let's substitute that first of all. So A11 is just 0 times the cofactor 11 plus 2 times the cofactor of 1, 2 plus 1 times the cofactor of 1, 3. Now the thing is we have to find those cofactors. And so from what we learned previously about finding the matrix, finding the determinant of a 2 by 2 matrix, this is how you would do it. So let's start from the beginning because this is normally how you would do it. So in order to find C11 here, we are going to do 0 plus, so C11 is this position here, and actually it's 0, right? So we can ignore this one, so we can just make that 0 here. So we don't need to find the cofactor of 11, but we do need to find the cofactor of 1, 2. So remember how to find that is you circle this number here, you cross out that row, delete that column, and then it's the remaining matrix that you find it for. Now we do have to remember the sign for it. So let's put this all together. We remember the formula or hopefully we remember the formula, or seeing the formula, to find the cofactor, ij, that is -1, and then raised to the I plus j, so that tells us what sign it is, multiplied by the minor. Okay, so we're really trying to find the minor, and then the cofactor is just the correct sign. So that's finding the determinant of what's left over. So therefore this is 2 times -1, and this is the 1, 2. So first row plus the second column, right? C12, so 1, 2, and then the leftover matrix here is 3, 2, 4, and 1. Okay, so that's the cofactor of C12. And then now let's do the other one. So plus 1, and then to get the correct sign, it's -1, and then raised to the 1 plus 3. And then so let me erase what we have here. And so what I do is I delete this row, that column. So 3, -1, 4, and 0. And then that should help us find the determinant. So let's work with this here. So 2 to the -1 raised to the 1 plus 2, so that's odd. So that tells me this is going to be negative. So this is -2 times whatever the determinant is here. So remember, to find the determinant, we're multiplying 3 times 1, and then minus 4 times 2. Then let's do the next one. So this is plus 1 plus 3 up here. That's positive. It's even 4. So therefore, it's just going to keep the same sign. So therefore, it's a +1 times whatever the determinant is here. 3 times 0 minus a -1 times 4. So let's simplify. This is -2 times 3 minus 8. And then plus 0 minus is a plus 4. So this is -2 times -5 plus 4. So this is 10 plus 4. So therefore, the determinant is 14. So that is one way, I'm going to call that method 1 of finding the determinant of a matrix. And this is by expanding by cofactors. So here is a different method that you can use, method 2. So how this works is that we're going to take this matrix here. We're going to rewrite it. So just rewrite the entire matrix. So this is 0, 2, 1, 3, negative 1, and 2, 4, 0, and 1. After you rewrite the matrix, what you do is you rewrite the first 2 columns to the right of it. So what I mean is we're going to write 0, 3, and 4 right next to it, 0, 3, and 4, and then we write the next column, 2, negative 1, and 0. So what happens next is that what you're going to do is we're going to add the products going down here, so these 3, and then we're going to subtract the products of the ones going up. Now again, this works for a 3 by 3 matrix. Okay, so 3 by 3 matrix. So let's try that. So let's multiply this out. So I'm going to write all the numbers. So I'm starting with going down here, this one. So this is 0 times negative 1 times 1 plus 2 times 2 times 4 plus 1 times 3 times 0. So those are the 3 diagonals. Then we're going to subtract the diagonals going upwards. So this is minus 4 times negative 1 times 1 minus 0 times 2 times 0 minus 1 times 3 times 2. So let's finish this out. So 0, I'm going to cross out my zeros just so I don't accidentally add those incorrectly or subtract it incorrectly. So zeros, anything with a 0 goes away. So let's finish it out. So 2 times 2 is 4, 4 times 4, this is 16. Negative 4 times negative 1 is a positive 4. Then we have a negative 3 times 2, which is a negative 6. So 16 minus 6 is 10 plus 4. And notice my determinant is 14. So that is another way to do it. You will have to, of course, be very careful that you don't mix up the signs. You remember which ones you're subtracting and adding. But that is the second method of finding the determinant. So it's up to you as to what method you want to use. But let's try it out in the next example. So here, find the determinant of A. You can either find it by expanding the cofactors like method 1 here, or by method 2 by doing the diagonal method. I'll just call it the diagonal method. And so just rewriting the matrix, the first 2 columns on the right, and then, that whole method there. So try this out. So if you tried it out, method 1, so if you expanded by cofactors, you would write this out first of all. You would write the A11 C11 plus A12 C12 plus A13 C13, and then the A is 3, so 3 times C11 plus 4 times C12 plus negative 2 times C13. And then you would write, so you write the number here, 3 times the negative 1, that is 1, 1, that's just squared, right? So that's one way to rewrite that. And then the determinant of what's left over in here. Plus 4 times the negative 1 to the 3rd power. So you know it's going to be negative, right? So I put the signs there to help me out. And then the determinant of what's left over, which is 3, 0, negative 1, 1. And then minus 2 times negative 1 to the 4th power. That will keep the same sign. And then this is what's left over is the 3, 5, negative 1, and 4. And then you find the determinants of each, and you find that it's negative 31. Now, if you use method 2, so if you notice method 2 is kind of shorter. Again, it's up to you what you want to use. And so you still get the same thing. Again, just being very careful of multiplying and adding and subtracting correctly, applying your signs correctly.